Hello guys, welcome to my channel Physics Words of Shantanu. I'm making this video after a long while. So today we will discuss about A.C. Verma's Concepts of Physics chapter 3, which is rest and motion kinematics, and we'll solve the problems from problem number 1 to problem number 8 of the exercises. So looking at question number 1, it says a man has to go 50 meter due north, 40 meter due east, and 20 meter due south to reach a field. So, what distance he has to walk to reach the field? And there is another question: what is the displacement from his house to the field? So here is the other corresponding figures. Taking this as north and this as east, this as south and this as west. This figure has been done according as the question, and here O is the initial point or starting point. Therefore, distance traveled is equal to OA plus AB plus BC, that is equal to 50 plus 40 plus 20 meter is equal to 110 meter. This is the distance traveled. Now his displacement is equal to OC from and direction is from O to C, since it is a vector quantity. Its magnitude is OC is equal to root over OD square plus CD square from Pythagoras theorem, and by calculating we get its magnitude is equal to 50 meter. And for direction we take, let OC makes an angle theta with the direction OD. Therefore, from in triangle OCD, tan theta is equal to CD over OD. So it is equal to 50 minus 20, which is CD, divided by 40, which is OD, is equal to 30 over 40 is equal to 3 over 4. Therefore, theta is equal to tan inverse 3 by 4. It denotes the direction of the displacement. So the final answer would be his displacement from his house to the field is 50 meter, tan inverse 3 by 4, north to east, because this is the northeast direction, right? If this is north and this is east, this is north and this is east, so this is the northeast direction. Now coming to the next question number 2. It says a particle starts from origin, goes along the x-axis to the point 20 meter 0, and then returns along the same line to the point minus 20 meter 0. Find the distance and displacement of the particle during the trip. So here is the corresponding figure. From origin it first goes to 20 meter and 0 along x-axis, then it come back surface to and traverses to AB and goes to B, whose coordinates are minus 20 meter, 0. So here O is the origin. So distance traveled is equal to 20 meter plus 20 meter plus 20 meter is equal to 60 meter. But displacement is O to B, right? That is OB is equal to minus 20 meter, 0, and that is 20 meter along the negative direction of x-axis. This negative sign denotes that it is along the negative x-axis direction. And we know the displacement is the shortest distance between final and initial position. Initially the particle was at O and final position of the particle is B. So obviously the displacement is minus 20 meter, 0. Now let's come to question number 3. It says it is 260 km from Patna to Ranchi by air and 320 km by road. The aeroplane takes 30 minutes to go from Patna to Ranchi, whereas a deluxe bus takes 8 hours. Question number 1 is find the average speed of the plane. Question number 2, find the average speed of the bus. And 3 and 4 are find the average velocity of the plane and average velocity of the bus. Now we take that the plane goes along the in straight path, that is along a straight line in air. Therefore, average speed of the plane is equal to distance over time is equal to 260 kilometer over 30 minutes, that is 30 over 60 hour. So the answer is 520 kilometer per hour. And average speed of the bus distance for bus distance is 320 kilometer per hour, 320 kilometer, and it takes 8 hours to traverse this distance. So the speed is 320 over 8 kilometer per hour is equal to 40 kilometer per hour. Now as I have said already, the plane goes in straight path. Therefore, average velocity is equal to 260 kilometer divided by 0.5 hour. From Patna to Ranchi is equal to 520 kilometer per hour from Patna to Ranchi. Now the plane goes in straight path, so it is the shortest distance. So for displacement, this value, that is 260 kilometer, will be used for bus also. Therefore, for bus, average velocity is equal to 260 kilometer divided by 8 hours is equal to 320 is equal to 32.5 kilometer per hour from Patna to Ranchi. All right. Now discuss question number 4. It says, when a person leaves home by his car, the meter reads 12,352 kilometer. That is, it is a starting reading. When he returns home after 2 hours, the reading is 12,416 kilometer. That is the final reading. So what is the average speed of the car during this period, and what is the average velocity? Now delta t is equal to 2 hours, there is a time interval, and distance traveled is equal to final reading minus initial reading, which is equal to 64 kilometer. Therefore, average speed is equal to distance over time is equal to 64 kilometer over 2 hours is equal to 32 kilometer per hour. Now displacement is 0 because he starts from his home and returns to his home. Therefore, velocity is equal to displacement over time is equal to 0 over 2 hour is equal to 0. Now question number 5 says, an athlete takes 2 seconds to reach his maximum speed of 18 km per hour. What is the magnitude of his average acceleration? Now initial velocity u is equal to 0, final velocity v is equal to 18 km per hour, which is, by calculating, we get 5 meter per second. Now time taken to reach final velocity is equal to 2 seconds. Now we know v is equal to u plus ft. Therefore, f is equal to v minus u by t. F is here average acceleration is equal to v minus u by t is equal to 5 minus 0 over 2 meter per second square is equal to 2.5 meter per second square. Here t is equal to 2 seconds. So we have put that here and get this as acceleration. Now let's come to question number 6. It says, the speed of a car as a function of time is shown in figure. Find the distance traveled by the car in 8 seconds and its acceleration. And the corresponding graph is given here. This is the corresponding figure. Okay. Now from the figure we get, in the interval of 8 seconds, the velocity changes from 0 to 20 meter per second, right? So average acceleration is equal to 20 meter per second over 8 seconds, and calculating we get 2 meter per second square. That is change in velocity, and that is average acceleration is change in velocity over time interval, right? And here we get 2.5 meter per second square. This is the answer. Now let's deal with question number 7. It says, the acceleration of a car started at t is equal to 0 varies with time as shown in figure. Here is the figure. Take a look at it carefully. Find the distance traveled in 30 seconds and draw the position time graph. Now this is the acceleration time graph, and we have to find the distance traveled in 30 seconds and draw the position time graph. Now in the first 10 second, S1 is equal to ut plus half at square, this formula. Now u is equal to 0 because the card starts at t is equal to 0. So it only remains half at square. That is half into 5 into t square, that is 10 square feet is equal to 250 feet. That is in 10 seconds it covers 250 feet. Now at t is equal to 10 seconds, v is equal to u plus a t, that is 0 plus 5 into 10 feet per second is equal to 50 feet per second. Therefore S2, which is where S2 is the distance traveled between t is equal to 10 seconds and t is equal to 20 seconds, where there is no acceleration. So S2 will be only v into t, because a is equal to 0 here, this formula, a is 0 or f is 0, so it is only vt. V is equal to 10 seconds is equal to 50 into 10 feet is equal to 500 feet. Now between t is equal to 20 second and t is equal to 30 second, a is equal to minus 5 feet per second square. So like before, here we also calculate SG is equal to 50 into 30 minus 20 minus half into 5 into 30 minus 2 20 whole square feet. Now the minus sign signifies that it is the retardation, that is negative acceleration. So calculating, we get 500 minus 250 feet is equal to 250 feet. Therefore total distance traveled is equal to S1 plus S2 plus S3 is equal to 250 plus 500 plus 250 feet is equal to 1000 feet. Right, is equal to 1000 feet. So this is the answer. Now the position time graph is shown as follows. In 10 seconds, right, it goes 250 feet. In 20 seconds it goes 750 feet, and in 30 seconds it goes 1000 feet. So this is the AST curve or displacement time graph. Now let's come to the final question for today. Here a figure is given, a VT graph, that is the velocity time graph. The figure shows the graph of velocity versus time for a particle going along the x-axis. Find the acceleration, the distance traveled in 0 to 10 seconds, and the displacement in 0 to 10 seconds. Here is the graph. Look at it carefully. When t is equal to 0, v was 2 seconds. At t is equal to 5 seconds, it was 4 seconds, and at t is equal to 4 meter per second. At t is equal to 10 seconds, v is equal to 8 meter per second. All right. Therefore, from the graph, we have seen that initial velocity is u equal to 2 meter per second. Final velocity v is equal to 8 meter per second. Time interval is equal to 10 seconds divided by t. Therefore, acceleration is like previous, v minus u over t is equal to 8 minus 2 over 10 meter per second square is equal to 6 over 10 meter per second square is equal to 0.6 meter per second square. This is the answer. And what is the distance? The formula for distance is s is equal to ut plus half at square. U is equal to 2, t is equal to 10, and a is equal to 0.6. That we have got from 8a. So calculating, we get it is equal to 20 plus 30 meter is equal to 50 meter. This is the answer. And here displacement is same as the distance traveled. Therefore displacement is equal to 50 meter. So that's all for today, guys. Hope you enjoyed the video. Kindly give it a thumbs up and share with your friends, and don't forget to subscribe to my channel so that I get inspired to make more such videos. Thank you.